Okay, good day everyone. Welcome back sa atong discussion for this course. We are now on chapter 8 of our course, Electricity and Magnetism. So for this chapter, we'll be talking about magnetic fields and okay, magnetic fields and of course its sources. So magnetic fields and its sources. So we'll be studying in this chapter the sources of magnetic fields up closer. So how are magnetic fields created in the first place? We studied and learned from previous chapter that a charge is a source of electric field and that electric field exerts a force on a charge. We've known that before in our previous chapters, specifically on chapter 1 and chapter 2. Also, magnetic fields do exert a force on a moving charge. So we discussed that in the previous chapter on chapter 7, and that magnetic field can interact or can affect only on moving charges but not on static. And so the question then arises, does charge create a magnetic field only when the charge is moving? So that's a very good question. Well, the answer is, in short, yes, and also a no. So we will discuss that later as we progress on this discussion. So the origin of the magnetic field, of course, is moving charges. That's a fact. That's yeah, moving charges. But maybe mag-wonder sa why are permanent magnets the one that uh, let's say a magnet bar, the one that is present and that is found on on the front door or on the door sa imuhang refrigerator, di ba, na makay ginapilit diha nga something, and that's a permanent magnet. And it seems like, as seen from the outside, there's no charge moving, right? But we will discuss it later nga, there's actually charge moving. That's why it creates a magnetic field. So it's a permanent magnet siya. Unlike sa coil or a rod or a wire na nakaipaagi nga current, that creates also a magnetic field because there's a current and a current is a moving charge. And a moving charge creates magnetic field. Okay? So this magnetic field, due to various distributions, can be evaluated, and Ampere's law will be useful in calculating the magnetic field of a highly, let's say, symmetric configuration that is carrying a steady current. So the way magnetic fields affect in matter can be explained on the basis of atomic magnetic moments, which will be briefly discussed in this chapter as well. So in this chapter, we will understand the nature of magnetic field due to a moving charged particle, and also we will describe and understand the magnetic field produced by a current carrying conductor. And at the same time, we will also be able to understand why wires carrying current in the same direction will attract while carrying the opposite direction of currents will repel. And we will be comparing and contrasting the magnetic field produced by a current carrying wire bent into a circle and that of a bar magnet. And then we'll also define what is Ampere's law and what it tells us about magnetic fields. And also we'll discuss this that magnetic effects in matter can be explained on the basis of atomic magnetic moments. So atomic na ni siya nga level or even quantum. Okay, so let's talk about the Biot-Savart. So Biot and Savart conducted experiments on the force exerted by an electric current on a nearby magnet. Okay, so we have a let's say this is a magnet, bar magnet, and then you have, let's say, a nearby, say, rod. This is a current carrying rod or wire. So naa siya effect. So in this case, so that's for the Bayot Savart 2, they try to they experimented this setup. So they arrived at a mathematical expression that gives the magnetic field at some point in space due to a current. So due to a current, naman na siya, maproduce man na siya magnetic field in this, inana ang iyahang orientation, right, circular. So the magnetic field circles around sa imuhang uh, rod or sa imuhang wire. So the magnetic field described by the Biot-Savart law is the field due to a given current carrying a conductor. Given a current carrying conductor. So please do not confuse this field with any external field applied to the conductor for some other source, say a permanent magnet. So, and according to the Biot-Savart law, in the observations, it can be summarized in the mathematical equation called the Biot-Savart law. So this one. So they have this equation, and mu naught is the constant called the permeability of free space, and is given by this value in terms of Tesla and uh, of this unit ampere and then meter. Okay, and ds is a small segment in a wire, and r is the unit vector pointing perpendicular to this uh, small segment. Okay, and then you have 4 pi and then r squared. So it's like you have your wire. This is your, say this is your r, and then this is your small segment ds, and then this is your dr. Okay, so your point P is the magnetic field that is felt at this point due to the presence of this current carrying conductor, which produces magnetic field. So kani calculus naman ni siya nga level. So you have your dB here, right? So if you apply ka diha og integral, what you will actually get is B and then constant, and you have this. So constant po ang I. So mabili nimo is ana na lang, ds cross r over r squared. So that's why kani aka din. So the goal is to evaluate this integral for a given distribution. Let's say for a line, ds. For a volume, you have ds for a line, d-rho for a surface. Okay, sorry for that. Then you have your d tau for volume. Okay. Okay. Some things to note on magnetic field compared to electric field. So the magnitude of the magnetic field varies as the inverse square of the distance from the source. So similar po din siya sa electric field. The electric field due to a point charge also varies as the inverse square of the distance of the charge, as shown in this equation, inverse square. Ang imong electric field is 1 over 4 pi epsilon naught Q1, Q2 over R squared. Mavary po siya inverse square, right? And the direction, the electric field created by the point charge is in radial direction. So ang electric field is siya? Electric field created by a point charge is radially outward. So it is divergent. But for a magnetic field created by a current, element is perpendicular to both the element ds and the unit vector r. So if this is your ds, this is r, so ang perpendicular po mo ang imong magnetic field. Okay, so we'll see that later on. An electric field is established by an isolated electric charge, but for magnetic field, there should be a current element that produces it. Okay? It must be part of an extended current distribution. So therefore, you must integrate over the entire current distribution. So for example, if you have a line and it somehow carries a current, a moving charge, we have to integrate over all this entire line. So take a look at this. So if you have your line here, so the question is unsa ka ang magnetic field na ma-feel at this particular point. Okay? So using the formula katong kani, this one. So ang formula actually is kani. Uh, you have B mu naught over 2 pi I. You have ds cross r over r square. Now in this case, this is your ds here, ds, and it is in x direction, so it is dx. Okay? So ato siya ilisan diha og dx. So no need to worry about this calculation if di mo familiar gyud sa pag-integrate this one, but I just have to show to you yung sa pag-derive ni siya nga formula. Okay? So this is dx, and then ang r nimo is this. So this is it makes an angle of this one theta. So this is actually just oh dx, and then sine, and then sine is this is y over this is r squared. So sine theta. Okay, take note nga ang dx cross r, this is dx sine theta. Okay, ang cross product is sine na siya ang iyang result. So sine theta here is opposite over hypotenuse, that's y over r squared. So sine theta, y over uh, this one, over r squared, where r squared is just x squared plus y squared. Okay, so imo siya i-substitute din na. And then I will not go into the details of how is this solved. So there's a technique in calculus, in mathematics, wherein this integral can be easily solved by using a particular technique. Okay, and in mathematics they call it trigonometric identities, and maybe just using the table of integral na nasa kodigo ba or formula nga wherein ma-solve na siya, wherein if you evaluate this integral evaluated from, let's say this is from negative, so negative x to positive x, or from negative a to positive a, this is a, so you will get this. Okay, so this formula, this is actually the magnetic field felt at this particular point, point P. Okay, so muna siya iyang value. Meaning, ang iyang magnetic field na ma-feel at point P due to the presence of this line charge na line or a wire carrying a current is proportional to the amount of current ang imuhang kung usa ka kusog ang current, and also the distance. This is, let's say this is A. Okay? So kung layo, of course, kung layo ang distance nilang duha, or dako ang P or dako ang A, mugamay po ng imong magnetic field. But if you increase the current, kusog po ng magnetic field na ma-exert din sa kanina point. Okay? So this is now for a circular loop. Okay, so notice nga medyo if you have so if you have this one. So for this is for a conducting wire, right? Muni ang A na distance A. Ang iyahang magnetic field niya is mhm, magnetic field niya is mu naught I over 2 pi A. But if it's a circular loop, so like say nana siya. So unsa ang magnetic field at the center. So it's given by mu naught, this is mu naught I. Mu naught I over 2A. So take a look at the difference. So wala lang siya pi nga factor. Okay. So muna ang strength sa imuhang magnetic field at that particular point. So this will be very important kaning circular loop because we will apply this to a bunch of n circular loops. So what if n circular loops? So let's say na ako ana circular loops. Or example lang niya is kana bitawng coil of wire. I think naka-experiment naman na before sa high school wherein mag-create ng super magnet. Sa super magnet na amoy wire, right? Na amoy wire tapos inyong ilukot-lukot di ba diha ang kanang coil of wire. Ilukot-lukot mo siya. So in principle, what you actually are individual is like a circular loop. Daghan lang siya. So in this case, n circular loops. So mo follow siya og equation sa kaning fundamentally equation sa individual circular loop. But since n kabuok loops, the magnetic field for this is mu naught n I over 2a. So this is for the circular loops, n circular loop, and this is for a single circular loop, while this one is for a conducting wire straight. Okay. So as you can see here, this is the magnetic field of an individual circular loop. So ang direction niya is inana sa padulong. So take note nga ang magnetic field direction is unlike sa electric field nga mo diverge siya. For the magnetic field ang iyang direction is mo converge. So mo circular siya. Mo lagi siya mo meet gyud siya mo balik siya kung asa siya gikan. So nakay north, nakoy south. Okay. So figure A, this one shows the magnetic field lines surrounding a current loop, while for figure B, that's the bar magnet. So actually similar sila, di ba, og ilahang shape sa iyang magnetic field because uh, ang direction gyud sa imong magnetic field is inana gyud na siya. We have from north. So always siya mo seek sa iyang south. So na siya diri. Okay. So take note of the similarity sa ilahang pattern. Now let's take a look at magnetic force between two parallel conductors. Okay. So as you can see here in this figure, you have two parallel wires carry a steady current. Okay, so ang direction sa current is padulong dinhi. The same sila og direction padulong dinha. So take a look at the direction sa magnetic field. So if you have a wire carrying a current in this direction, so the magnetic field is kaning color green, ang direction sa magnetic field. So actually pagawas na siya sa page kung imuha siyang i-imagine. So pagawas sa imuhang screen, kumbaga. Okay? So because of this, the field B2 due to current in this one, due to current in wire 2, it exerts a force on wire F1 which is in this direction. Okay? So mogamit ra gyud ta ana og right hand rule. So as a right hand rule, ang imong upat ka fingers is padulong dinhi. So I hope ma-imagine ninyo. Nag-discuss naman tayo sa previous nga chapter sa ang paggamit sa right hand rule. So your four fingers should be pointing towards in this direction, kaning I1. And then i-curl ninyo siya. So pag inyo siyang i-close ba kung asa padulong ang magnetic field. So padulong mo siya sa gawa sa padulong sa kanina paggawa sa screen or sa page. Okay? And then pag close nimo, kung asa to ang direction na sa imong thumb is going this way downward. So it's the force is downward. Okay? This is F1 and doing also the same thing sa I2. So sa I2 is ang magnetic field is padulong sa sulod. Okay, padulong sa sulod. And using right hand rule, ang imuhang F2 is paana na pod siya. Okay? So this is F2. So giving a net force nga attraction, okay? Attraction ang iyang. So attractive force na siya. So this is a very peculiar thing sa to na-experiment pa sila sa nag-experiment pa si Bayot and Sawart before nga when they try to bring two parallel wires together and the same ang direction sa ilang current, na-notice nila nga na ay attraction. Okay? So the attraction, the attractive force is due to this mechanism. Okay? Na ang magnetic force is in this direction sa kaning wire 1 and sa wire 2 is diha pod pasaka ang direction niya ang attraction. Okay? So parallel conductors carrying currents in the same direction will attract each other. And if balihon nimo na siya ang current sa I2 is dili na siya padulong, so mo repel na siya. Okay? Opposite direction of currents in the parallel wires results in repulsion. Okay? So unlike sa katong electric charge bitaw nga if you have same charges mo repel. Sa kani is if same direction, so same direction magka-vibe sila, attract. Somehow mo relate siya sa real life. The same mo aspirations and goals, you attract each other, right? So it's like this, the same direction ang imong current mo attract sila. But if opposite gani ang ilang direction sa current, they tend to repel each other. And the magnitude of the force is given by this. So you have F1 times I1 LB2. So, kani siya gikan naman na siya sa formula nga I L cross B. So, mo na yung formula sa imuhang magnetic force. And then since perpendicular man na siya, so it's just ILB. Okay? Or ILB. Where I is current 1, B2 is magnetic field due to the current in wire 2. Okay. So kani siya is gikan na siya sa F equals mu naught to F1 mu naught I1 B2 and then B2 magnet atong formula sa ato ang kani recall. This is B. Mu naught I over 2A and then P2, so this I is I2. So this is mu naught. Oh, wala na siya mu naught din. Formula ani, this is I1 L B2, where B2 is mu naught I2 over 2 pi A. So, kung imo siya i-substitute din ha, you get this. So, this simply tells us that the force exerted on wire 1 and vice versa, kung force exerted on F2 is the same, attractive siya if same direction, repulsive if opposite ang direction sa current. Proportional siya sa length proportional siya sa magnitude sa both currents. Force, kung dako ang current sa I1 and I2, dako po ang yung force of attraction or repulsion. And inversely proportional siya sa distance. Kung magkalayo magkadako ang distance, nakagamay ang force of attraction or repulsion. Okay? And the result is often expressed in magnetic force between two wires. And this can also be given as the force per unit length. So, pwede siya ma-express as this. Kuha nimo ang L divide ibutang sa pikas to get this. Force per unit length is given by this. Okay, and the force between two parallel lines or parallel wires can be used to define the ampere. So, ampere is unit man na siya sa current, diba? So, when the magnitude of the force per unit length between two long parallel wires that carry identical currents are separated by 1 meter is kani-gani ang iyahang magnetic force. So, the current in each wire is defined to be 1 ampere. Okay? And we call it these international units, standard units sa imong charge is coulomb, and it is defined in terms of ampere. Okay? So, ang current is ampere man at charge per second, right? So, when a conductor carries a steady current of 1 ampere, the quantity of charge that flows through a cross section of the conductor is in 1 second is 1 coulomb. So, this is 1 coulomb per second, or this is 1 ampere. So, it was French physicist André Marie Ampere which was credited with the discovery, who was credited with the discovery of electromagnetism and the relationship between electric current and magnetic fields. And he also worked in mathematics. Okay? So the magnetic field lines are circles concentric with the wire as shown in this figure. So ang kanimong finger, ang pag-curl niya, mo na siya ang direction sa iyang magnetic field. And then ang imong thumb, mo na siya ang direction sa imong current. Okay? So the field lines lie in planes perpendicular to the wire. The magnitude of the field is constant on any circle of radius A. So the right-hand rule for determining the direction on the field is shown in this figure. So muna siya ang imuhang sa paggamit ang right-hand rule. So a compass can be used to detect the magnetic field because dili man ni makita ang imong magnetic field. So one way to detect if naabagid ang magnetic field is to use a compass. So as you can see, if wala pa naka-on ang current, so wala pa'y current, ang imong compass is mo point siya in the same direction, and manotice niyo nga nagpoint na siya actually sa Earth's North Pole. Okay, but once you turn on the magnetic field, turn on the current, so it creates a magnetic field, and that magnetic field can be detected by a compass, and manotice niyo nga mo circle around na siya. Okay, depende kung asa padulong ang current. So if this is the current direction, so imong compass mo point na siya circular. So muna ang direction sa iyang magnetic field. Using right hand rule muna iyang direction sa magnetic field. So muna siya this one. So the compass needle deflect in the direction of tangent to the circle. So this shows the direction of the magnetic field produced by the wire. And if the current is reversed, mo reverse po ang direction sa magnetic field or sa imong compass. So mabali po na siya. So the circular magnetic field around the wire is shown by the iron filings. So ma-detect nimo nga mo na ang direction sa magnetic field because the iron filings follows the direction of the magnetic field and it's circular. Okay? In that way, we can now then define the Ampere's law based on this direction sa imong magnetic field that circles around. So in mathematics, in calculus, we can use the language in mathematics or calculus to describe mathematically or quantitatively the the magnetic field and also the current is given by this formula. Okay, so it simply says that the magnetic field that dotted with the segment sa imong line sa direction sa magnetic field, integrate mo na siya over a closed surface or a closed line integral, it's proportional to the current. Okay? So, mo na ang iyang gusto ipasabot. So, You have a circular here, kani siya. Integrate mo na siya over a small segment and integrate over the entire closed line integral, and that is proportional to the amount of current with some constant mu naught. Okay, so this is what we call the Ampere's law. And this equation is similar to Gauss's law. Okay, so Gauss's law is katong electric field man na siya. So this is the Gauss's law, right? If maka-recall pa mo ano, Q enclosed over epsilon naught. So the electric field, yung integral niya over a Gaussian surface is equal to the charge that it enclosed over some constant. Kani siya is the magnetic field enclosed over a line integral. Okay, kani man line man siya, this one, over that is proportional to the current sa imong wire. Okay. So take a look at this example. So we can calculate the magnetic field at a distance r from the center of a wire. This is a wire carrying a steady current of I. Okay. So magamit naman ta na ang kaning formula, kani siya Ampere law. So it's just B, tapos ang integral sa line, this is the line integral. And notice na this is just a circle. So equation sa circle, unsa man ang equation sa imuhang kaninga line sa circle, this is a circumference, right? So the circumference is just 2 pi r equals mu naught I. Okay? So simple as yeah, we can get the magnetic field just mu naught I over 2 pi r. Familiar naman mo aning equation, di ba? Mao man sa katong sa equation sa conducting wire. Tara, balik. Tara, this is the equation sa conducting wire. Kana. Okay? Okay, that's the equation for the conducting wire. Now, what about this one for a toroid? Okay, so imo siyang gi-circle around. So, the same formula nga po nagamiton, the Ampere's law. So, this is equation sa circle, circumference niya. And then, this is n turn. Okay. Composed naman na siya of individual circle, right? Individual circular loop. But, daghan na siya n times. N kabog. Pwede kung pila ang turns. So, n. So, it's given by this, right? Familiar sa daan na n circular loop. So, this is for n circular loop. Meaning, it's like, katulad itong experiment niyo sa una, project ba na creating a supermagnet. Mas makusog ang imong supermagnet, imong magnetic field nga gihang gi-exert if daghan ang turns, kusog ang current, or gamay ang R. Right? So if gamay ang R, meaning it's like ay imong kasi gamay kay siya nga conducting wire. So tapos daghan kay siya turns, expect na dako na i-produce nga magnetic field. Okay. So we'll skip this one. Okay, so magnetic field, going back sa katong sa atong introduction, that magnetic field is produced by a moving charge. Okay, that's why if you have a loop tapos nag-carry siya og current in this direction, right, it creates magnetic field because magnetic field is produced by a current, okay, or a moving charge. But you may ask, how about those bar magnets? Wala man na siya kuryente, right? And wala siya kuryente, and there seems to be no moving charge. But how come na siya magnetic field? Kaya may exhibit siya magnetic property. The answer is naagihapon siya magnetic fields because of a moving charge, okay? And na siya moving charge if you look at the atomic level. So sa atomic level, you have your atom, right? Nucleus, and then you have an electron. And an electron is a moving charge. It's constantly moving, right? Let's say circular direction. And so that creates magnetic field, right? So each individual atom will have its own magnetic moment. Okay, that's why bar magnets do exhibit magnetic properties even though wala siya current. Okay, so naagihapon siya somehow technically current at the atomic level because of this magnetic moment niya nga property. Okay, so this is on the atomic level. So described gyapon siya by this current loop. It's like a loop gihapon sa imong atomic, sa imong atom. So that will explain why some materials exhibit strong magnetic properties. So the electrons move in circular orbits, and the orbiting electron constitutes a tiny current loop. And the magnetic moment of the electron is associated with this orbital motion is shown in this figure. Okay? So in this direction, so naa siya angular momentum. This one, L. That's the angular momentum padulong sa taas. So in classical physics, angular momentum is defined by this formula, mvr. So mass of the electron, velocity of the electron, and then the radius niya. And opposite to that is the magnetic moment. Okay? So okay, so this is the basta opposite na siya sa yung angular momentum direction and the magnetic moment. So that's the magnetic moment of the electron that is associated with this orbital motion. Okay. So the electron has an angular momentum L in one direction and a magnetic moment mu in the opposite direction. So if magamit ang right hand rule, it's like imong i-curl ang imong kuan. The direction of the current is this. Okay? So kung i-curl nimo ang imong kamot, ang direction sa imong thumb downward, which is that's the direction of the magnetic moment because ang current is positive na, di ba? Ato ang notation is padulo ang direction sa current is positive diha. And ang angular momentum is ang direction sa electron gud mismo nga nag-move, which is in this direction. So opposite ang iyang direction sa angular momentum and the magnetic moment. So we can get the current associated with this orbiting electron. So current is just charge per unit time or charge per second or charge and then T is the period. Okay? Total time nga na-revolve niya ang imong circumference sa imong circle. Okay, so you have your charge and then your period is just 2 pi r over v. Okay, the circumference over the velocity. So imo siya i-substitute diha, you get this. Okay. And then the magnetic moment is given by this. And we can now have the final expression for the magnetic moment in terms of angular momentum. So it's given by this. Okay. So ang imong kani siya. So this one, if multiplyan ako na siya og m over m, v times r. Okay. And then this one, mvr, is just L. So that would be 1/2 E L over m. Okay. So 1 is here. This is the magnetic moment in terms of angular momentum. Okay. So this will simply tell you nga if dako ang angular momentum, meaning kusog ang imong velocity, kusog ang tuyok, kusog dako ang charge, that would constitute to a bigger magnetic moment. That's why some materials are kusog ang iyang magnetic properties compared to the others. And there are three kinds of magnetic properties na ma-exhibit sa kada material. We have paramagnetic, diamagnetic, and ferromagnetic. Okay, so we'll discuss this one. So the magnetic moment of the electron is proportional to its angular momentum. So the vectors L and mu point in opposite directions. Ito nakita ganina. Because the electron is negatively charged. So in quantum physics, quantum physics indicates that angular momentum is quantized. So when you say quantized, in quantum, it's like discrete siya. So it can never come in bungkig siya nga number. So let's say multiple of 1 or multiple of n number, basta dili siya continuous ang iyang number. Okay? So in most substances, the magnetic moment of one electron is cancelled by that of another electron orbiting in the same direction. And that is why the net result is a magnetic effect produced by the orbital motion of the electron is either zero or very small. So if you have an iron bar, so an iron bar doesn't exhibit magnetic properties because ang iyang mga, let's say, ang direction sa, let's say, if you have your iron bar, kada atom ana is naa siya direction sa iyang magnetic moment. So, muli ang direction ng magnetic moment, diha, tapos dinhi is, and so on. And then this one cancels. So, overall, ang iyang magnetic properties is zero. Okay, so wala siya magnetic property. There can only be a magnetic property, just like a permanent magnet, bar magnet, na gina-attach sa inyong refrigerator, na siya magnetic properties because ang iyang magnetic moment would tend to align in the same direction. Okay? So, pwede na siya ma-arrange nimo nga in such a way nga ang magnetic moment sa kada atom sa imong material points in the same direction. So, you have a permanent magnet. Okay. Another thing also sa imong electrons, it has an intrinsic property called spin that also contributes to the magnetic moment. So, the total magnetic moment is the sum of the angular katong momentum, magnetic moment, and the intrinsic niya nga spin. So, medyo advanced na ni siya. So, that's the idea sa imong atomic na siya nga level. So, if you have this one, imong magnetic moment sa imong spin because of the electron spin. So, and they have this formula, ang iyang expression. So you have substances that exhibit strong magnetic effects. We call that ferromagnet or ferromagnetic object or material. And some examples of ferromagnetic materials are iron, cobalt, nickel, gadolinium, dysprosium. So they contain permanent atomic magnetic moments that tend to align parallel to each other or even in a weak external magnetic field. So if you have an external magnetic field, so ang imuhang magnetic moments niya would tend to align parallel to that weak external magnetic field. So may exhibit din siya og magnetic property. Okay? So this is what I showed you kaganina. The direction of the unmagnetized substance, they are randomly distributed ang iyang direction. So cancel siya with each other. And so the net magnetic moment is zero. And we also have paramagnet. So paramagnetic substances have small but positive magnetism, unlike sa ferromagnets. So it results from the presence of atoms that have permanent magnetic moments, and these moments interact weakly with each other. And when placed in an external magnetic field, its atomic moments tend to line up with the field. And the alignment process competes with the thermal motion, which randomizes the moment orientation. So, dili kasi na ka-strong compared sa ferromagnets, right? And then lastly, we have diamagnetism. That is when an external magnetic field is applied to a diamagnetic substance, a weak magnetic moment is induced in the direction opposite to the applied field, unlike sa katong paramagnet and ferromagnet in the same direction siya. For the diamagnet, opposite to that. So diamagnetic substances are weakly repelled by a magnet, while the paramagnet and the ferromagnet mo-attract siya sa imong magnet. Okay? Weak, so only present when paramagnetism or paramagnetism do not exist. Okay, so uh, that's our discussion sa to magnetic field. That ends our discussion. So having this knowledge on magnetic properties on objects, and also that your atoms, individual atoms, do exhibit magnetic properties due to its magnetic moment and magnetic spin moment. So daghan kaya siyang application specifically sa kanang imuhang hard disk. So sa imong hard disk, katong original nga hard disk bitaw katong ang original nga hard disk is naggamit pa na siya og kanang magnetic moment. Okay? Gigamit niya ang magnetic moment sa each atom para ma-store ang information. Karon is SSD naman na siya, solid state. But for katong hard disk pa katong magtuyok bitaw nga kani siya is kanang naa siya magtuyok. Okay? Kani siya is wala naman ni siya ang SSD. Unlike kaning hard disk, I think nakaabot pa mo ani kaning hard disk 10 years ago. Ginagamit pa niya ang hard disk. So ang idea sa pag-store sa information is 1 and 0s naman na siya sa imuhang pag-store sa information. 1 would be ang imuhang magnetic moment points in the upward direction, 0 if inana ang iyang direction. So it utilizes the magnetic moment in each individual atoms to store information. So naggamit siya ani nga concept. Okay? This one. Okay, so that will be all for this topic, this discussion. And I think we are only left with one topic na lang yun for this course, and then mahuman na gid ta. So if you have questions regarding this chapter, or even the previous pa nga mga chapters, don't hesitate to contact me, message me sa Facebook. Well, I'm willing to give a comment or reply. You can email me or text me. Okay? And for the announcements on our final exam, ako ang i-post lang, or I'll just inform your mayor regarding it. And for the final exam, I think ako na I actually sa'yo na gid siya. I'll just make it easy for you. Kay we know nga nag-adjust patatanan sa ato ang scenario. So ana lang. So that would be all. Thank you and stay safe.